All right, and we are live. Hey everyone, and welcome back to another YouTube live streaming experiment. I'm still figuring out the logistics, the software, all of that. So I appreciate everyone bearing with me. I'll give everyone a couple of minutes to log in. And while you do that, if you're catching the recording, just a heads up, I will be teaching another live workshop, probably the last free one for the spring 2017 semester. And the topic will be all about synthesis and retrosynthesis in organic chemistry. So the workshop will take place on Saturday at 8 p.m. Eastern. So let me put the link in the chat. The URL is, let's see if I have it on my clipboard. No, I don't. layitforsci.com/workshop. It's going to be this Saturday at 8 p.m. Eastern, and we're going to be looking at synthesis and retrosynthesis. So it looks like we have a couple of students coming in. If you have an organic chemistry final coming up, go ahead and type your exam date in the chat. Also, let me know the biggest issues that you have or the biggest concerns you have regarding your upcoming exam. Just to give you some quick tips. First of all, if your exam is in the next 2 to 3 days, then it's really crunch time for you. I know last time I said, yeah, if you have your exam in 3 weeks, here's how you set up a calendar, right? That's the video I just published a few days ago. But if you have just a couple of days, then it's not so much that the video is too late, but you should already have been studying, you should already have been preparing. So our discussion today is more for students who do have the time. Say you have 1 week all the way up to 5 or 6 weeks. I know some students are testing as late as June. This is more for you, because what I want to focus on is how you can study to prepare for your final, how you can practice, how you can get through everything in time. So the workshop on Saturday is going to be on specifically how to tackle synthesis and retrosynthesis questions. If you're just finishing Orgo 1, you probably started on this topic. If you're in Orgo 2, you've been covering this topic all semester. And the issue that a lot of students have, and I say issue because this is the most common problem I see with students. When you have a chapter, you're learning that chapter, you work on some reactions, you work on some mechanisms, but it's typically related to that chapter. On the final, your professor will give you a starting molecule and a product where the steps in between will jump back and forth, something beginner, something advanced, something simple, something complicated from this chapter, from that chapter, and you have to figure out how to combine all of that, how to figure out, do I start with a reactant, do I start with a product, what if there's a railroad where I have a reactant and a reagent and what do you call it, like those blank boxes, I couldn't remember the word box, and you have to fill all of that in. The question is, how do you know how to go about it? How do you know how to figure it out? So I'm going to be covering all of that in Saturday's workshop. The link is layitforsci.com/workshop. It's free to sign up. It's at 8 p.m. Eastern, so make sure that you're there live. If you can't make it, you will miss it. But definitely give it a shot. So if you guys have questions regarding how to prepare for your Orgo final, that's specifically what I'm looking for, what I'm looking to answer today. And also if I can get some quick feedback on the quality of the video and the audio, because obviously with streaming, I'm not using my official recording software. I'm just using my computer's crummy webcam, the one that comes with it. Caitlin has a final on Monday, cumulative 1 and 2. Worry about remembering what different reagents do. Caitlin, you don't have a lot of time, so the simplest advice I can give you is look for patterns in the reagents. You'll notice that a lot of the reagents have a clue within them. For example, think about oxidation reactions, right? What is the common clue in your oxidation reagents? KMnO4, O3, Na2Cr2, O7. They have a lot of oxygen for oxidation. Think about your reducing agents, NaBH4, LaH, lithium aluminum hydride. They all have the hydrogens. So try to come up with a relationship between the way the reagent looks and some mental trigger or clue about the product as you study to help you. I mean, you don't have a lot of time till Monday, but you don't not have enough time because you do have a couple of days. Question, all the different synthesis reagents. what is your question, though? I don't see the question. The question, is it free? Yes, it's a free workshop, and it's free. If you show up live, you can attend, but the recording will not be available. It's not going to go on YouTube. It's going to be something private that goes into the Orgo Bootcamp. The Organic Chemistry Bootcamp is basically a crash course that goes through all of Orgo 1 or all of Orgo 2, depending on what you need. And then it has a lot of practice, including synthesis and retrosynthesis, which is the topic of the workshop. So the bootcamp is not free, but there's currently a discount if you're looking to sign up now. And if you can't make the live session, the bootcamp is on your own pace. So that's definitely something to consider. Question, how to study for mechanisms of Orgo. They are so much more detailed. The thing with mechanisms is repetition, but don't just blindly copy. Every time you do another step, ask yourself why and how. So you're going through a mechanism, for example, let's take a simple reaction, acid catalyzed hydration. What is going on? So what wants to attack? Think of what is the most positive, what is the most negative, and then why would they want to attack each other? The alkene has a pi bond. The pi bond have all those extra electrons, and they are nucleophilic. You have an acid catalyst in solution, which is an H+, is positive. It's an electrophile. So the nucleophile, the pi bond, attacks the electrophile. The electrons attack, break, draw that out as you practice. What happened as a result? Well, the pi bond broke. You have a hydrogen on the less substituted carbon. You have a carbocation on the more substituted carbon. That became your new electrophile. You now have a positive charge. But it's not just memorization, it's thinking about it. Okay, so this is positive. What would happen next? Something negative would be attracted to it. A nucleophile. What nucleophile do I have left in my solution? I have water. So do you see how I'm basically telling you to write it out step by step over and over? But I want you to think about what you're writing rather than just, okay, let me write this because this is what my book says. Question, the video is not streaming. I don't understand what you mean. Are you guys hearing me? I mean, if you're hearing me, then I assume the video is streaming, right? Otherwise, again, I'm still new to this. I've done this on the weekend, and then today this is my second time doing a live stream, so I am experimenting just as you are figuring this out as well, so we can figure this out together. What time is the workshop? It's at 8 p.m. Eastern time, so that is 8 p.m. New York time. If you are in the United States, it's 8 p.m. Eastern, 7 Central, 5 p.m. Pacific time, so California and so on. If you're in other countries, just look up local time and do a conversion, and that way you'll know what time it is for you. Just curious, who do we have here? Where are you coming from? And of course, when is your final exam? Go ahead and type it in so I know, and I don't see any more questions. So if you have any other questions, go ahead and type it in. If you're trying to figure out if it's just hitting you, wow, finals are just around the corner, what do I do? Then I want you to go watch the video that I published this week on how to create a study schedule. Because when I was in school, it just hit me one day, wow, finals are just around the corner, I have to study everything. But without knowing what to study when, it's hard to make sure you're gonna get through everything in time. So that video shows you how to set up a calendar no matter how many weeks you have left. And then you basically break down the chapters, build in some buffer, review, study days, so that if something happens, you're not left scrambling and staying up overnight trying to catch up. Questions are coming in. Will I be able to follow the workshops with my knowledge from high school chem and some other knowledge? This workshop is specifically for organic chemistry students preparing for a final. So that's Organic Chemistry 1 and Organic Chemistry 2. If you haven't taken organic chemistry, I don't know why you would show up to the workshop, because if you don't have a final coming up, I'm not sure, unless you're just looking to learn it for fun. I will assume that everyone in the workshop is at the same level. So if you start asking me questions like what's a carbon, which I did get on an Orgo workshop, I'm not going to answer it, only because I want to focus on answering the relevant questions. All right, more questions coming in. Let's see. Whoops, I clicked on the wrong thing. Hang on. There we go. All right, Ryan from Tampa, Florida. Finals on the 29th. That is just around the corner. Aditya from Georgia Tech. Final is next Friday. Why do you feel screwed? You have over a week to prepare. And if the question is, how do I cram everything? Then for those of you who are trying to figure out how you're going to get through everything in time, because you have so much to cover and you don't think the book will help, I recommend looking into the Organic Chemistry Bootcamp. I'll put the URL in the chat. The bootcamp, unlike the workshop, is not free, but there is currently a discount for students who are preparing for finals. And it basically takes you through everything. It's a crash course that goes through all of organic chemistry, and it goes through it with the finals in mind. So it's quick, it's tips, tricks, shortcuts, rather than let's take a step back, let's learn it slowly, because I know you don't have that kind of time. So Aditya, that might be something you want to look into. Drawstoria, I hope I said that right, says, with E2, I'm having trouble knowing how they act with big bulky bases. For example, the cycloalkanes with an H on a wedge, I can never get them right. The first thing I'm going to tell you is to watch my video that specifically covers big bulky bases. But the way you want to think of it is the little bases like to sneak in and grab that most substituted hydrogen because they can, and that will give you a more stable product. Zaitsev's rule, the more substituted the pi bond, the more stable it is. But if it's really, really big, it can't sneak in there because there's too much blocking it. It wants to come in from the side and kind of snip off a hydrogen and then make whatever pi bond it can. So if you have a ring, ask yourself, what is the least substituted hydrogen, and can I get it? Here's the trick. You know that whole anticoplanar thing you learned? Just think of it as transaxial. Can it be trans and axial? So you have the hydrogen and the leaving group, one is up, one is down, snip it off, and you're good to go. Gerald, I don't know how to pronounce that name, from Florida, testing in May 1st, so you definitely have some time. Keisha from Queens. Keisha, I'm in Long Island, so technically just a little bit away from Queens. That is awesome. And your final's in a month. You definitely have time to prepare. For you especially, make sure you watch the video I posted on creating a study schedule, because you have enough time to implement all of this. I can't even pronounce some of these names here. So the one that starts with APO, I live in Maryland, final on May 15th, pretty soon. Okay, so you definitely have enough time, and of course you are very welcome. You definitely have enough time to prepare. So what questions do you have in terms of how to start preparing now? Seeing a lot of yes, it's streaming, excellent. And Godson from Virginia, final on Wednesday, just around the corner. All right, I'm not seeing any more questions. So if you have any questions on how to prepare for your finals, go ahead and type it in now. I'll rant for a couple of minutes because I know there's a delay. And if you don't have a chance to type it in, or if you're catching the recording, because I will be posting this, then just go ahead and type a question in the comments, and within reason. I haven't been as good about answering the comments this semester just because very thankful, right? It's a good reason. The channel has grown to the point where I just, between emails and comments, it's a little bit overwhelming. So I have to get better with the system. But I'll specifically be looking out for the comments on this video because I know finals are coming up, and I am inviting you to post questions. Question: why will an aromatic aldehyde undergo the slowest rate of nitration? I'm not sure if you're talking about an electrophilic aromatic substitution, what you're comparing it to, right? When you say slowest, it's compared to what, and what. I'm going to assume that this is an EAS question. So think of the intermediate. I have a YouTube video on this specifically. It's leahforsyte.com/EAS. I'm going to put that in the chat. And look at what happens to the intermediate in the ring when you're adding another group. So the intermediate has a positive charge that's resonating, and the aldehyde has a partial positive charge, so they're fighting with each other, and that makes it very unhappy. Go through the video for the specifics. I assume this is the question. Okay, what are the best tricks to master resonance? Practice, but as you practice, make sure you understand. Ask yourself, why the heck is this doing what it's doing? Give it human characteristics. If I were electrons, would I want to go there if it's negative? No, because negative doesn't like negative, right? So pretend they're people, and then positives like negatives, negatives like positives, and try to go from that perspective. Question: would the synthesis retrosynthesis workshop include alcohol synthesis and making esters? Yes, so you're talking, for example, Williamson ether synthesis. We will cover a couple of that. What do you suggest I do trying to understand whether a mechanism will go SM1, substitution or elimination? This is, in my opinion, the most difficult organic chemistry 1 topic. So I want to say 20-ish videos on this. Watch the entire series from beginning to end. Before you even dive into the mechanisms, make sure you learn the checklist. Alkyl chain analysis, looking at the attacking. Is it a nucleophile or a base? What is your solvent? How does the leaving group play a role? And if you can understand all of that, you'll have a better chance with it. So the link, let me see if I can catch these links really quick. Let me put the link into the chat for you for substitution elimination. Make sure you study that. It's not going to be quick, so give yourself a few days to go through and really, really study it. Question, I'm just here to learn about medicinal chemistry. I don't know if you are in medical school or other medicinal chemistry, because I get emails from chemists looking to synthesize marijuana extracts and whatnot. I teach pen and paper chemistry. I teach you how to ace Orgo, how to prepare for exams. So I'm not actually sure what you're asking. Question, aldol clays, and when we will be given a product and have to provide the starting material and reactants, what's the tricks? I can't tell you the trick off the top of my head, but I do have some awesome tricks for this topic. It's basically a counting method that lets you instantly identify reactants and products. I don't have, I cover a little bit of it on the YouTube series. I'm going to put that in the comments later, site.com/enolate, and I covered in a lot more detail in the bootcamp. Question, I just failed my exam. That sucks. I'm sorry to hear that. If you fail the exam, ask yourself, is there anything I can do to bring up my grade for finals, or is it pretty much an F for this semester? And once you determine what your options are, you can figure out what your next step is. If you failed like this semester, if your grade is history, then it's really a question of preparing to do it over and doing well next semester. But if you have a chance to bring up your grade because the semester isn't over and it's just one exam, figure out what you have to do differently to ace your final. Alright guys, if there are any other questions, type it in. Otherwise, if you are struggling with synthesis and retrosynthesis, if you want to see how to make it easy, and dare I say, maybe make it a little bit fun, come join me on Saturday. The workshop will take place this Saturday at 8 p.m. Eastern. It's live only, so you have to show up live to be there. And the link is leahforsci.com/workshop. Yes, it's free, but you have to actually be there to participate. Question, regarding the aromatic aldehyde question, we're comparing aromatic. Okay, I would have to see these, so I'm not going to take tutoring questions over live stream because I'm trying to picture all the molecules in my head, and that's just not working for me this late at night. Yeah, so that's still all the same. For specific tutoring questions, the Orgo Bootcamp actually has a Facebook tutoring group, so you can draw it out, you can ask your questions, you can get help there. Definitely something you want to look into, if assuming it's not just one question that you're struggling with, if it's just wanting to get help with questions on a regular basis. Alright guys, with that, she's napping. So let's see if she wants to say goodbye. That's what I do in between sessions. I turn around and I play with Bunny because she's just so cute. The workshop will be, I want to say, about 90 minutes, maybe longer, depending on how much Q&A there is, how many questions come in. I would show up having not drank too much, so you don't have to go to the bathroom in the middle. Have your snacks ready, clear your calendar for 2 hours, just to make sure that you don't miss out. Alright guys, with that, have a great evening, and I'm hoping to see you guys on Saturday for what is potentially the very last live workshop for the spring semester for organic chemistry. I may be doing more workshops over the summer, but since not many students take Orgo in the summer compared to the fall and the spring, I'll probably just be doing MCAT workshops over the summer. Question, tips for the Orgo national exam. I have no idea what's on the exam, so my advice is to look it up and see what other people say, because people who have taken it will probably have the best advice for you. And final comment for the night, I'm still in high school. Well, if you're in high school, then this workshop isn't for you because it's an organic chemistry college level course that I'll be focusing on. So, I mean, kudos to you for studying this while you're still in high school. But then my other question will be, I mean, I don't know what time it is for you, but it's after 11 p.m. Eastern here, so why are you even still up? Go to sleep. All right, guys, have a good night, and I hope to see you all on Saturday.